Okay, let's start. Now, previously we learned about the corrosion reaction, right? We learned about corrosion reaction. Just recap, what we learned previously. So we learned there's a chemical reaction for corrosion. So it's important. This corrosion reaction is important. What will be different in coming tests or final exam will be the ingredient, right? The ingredient of the solution. Okay, so again, this one is more on a chemical reaction, or we call it equilibrium in a chemical reaction. So this will be important. So if you're not sure how to balance the chemical reaction, you need to open back your chemical textbook to balance the ion, positive, negative, and so on. Okay, so this is just a reminder. Okay, check my system. Okay, sorry. Let me redo my. Apologize for the disruption. Okay, right. Okay, let's continue. So this basically is what we learned in previous lecture. Okay, there is a chemical reaction. So there's an anodic, cathodic, cationic reaction, and corrosion. Beside all these reaction, corrosion might started or initiated by electrochemical reaction. Okay, so beside the condition that we have in the previous lecture that we covered, it might also started because of electrochemical reaction when there is impurity inside your metals. Okay, first factor that will initiate the electrochemical reaction. Why there is an electrochemical reaction can be started without any mixing or any additional or extra process. It is because inside the material itself you have impurity. So if this is a illustration. For example, you see all these molecule. So all the nets here represent the metals element. And just a recap, corrosion only happen in the metals type of material. So in the periodic table, you open up the periodic table. Those on the left hand side, 1 to 4, right? Column, you see column, right? Column 1, 2, 3, 4 will contribute to corrosion. So the first factor to initiate the electromagnetic reaction is metal impurities. Second one, the first factor that we mentioned is metal impurity. Second things that will contribute to the electrochemical reaction all right, will be when you have a different concentration. Same metal inside the material, right? Same metal, same type of metal in the material, but you're having a different concentration. Right? Let's say you have metal A and metal A, but metal A and metal B have different concentration when you make the material. So then it will initiate the reaction between them. Okay. So first, impurity. Second, different concentration. So as you can see here, this is that you can find in the chemical classes. If you dip two electrode in two different concentration, same solution, okay, same solution, but different concentration. On the left is 0.01 mole. On the right here, you have 1 mole. Again, I will expect you to know what is mole. 1 mole of solution, what is the definition of 1 mole, right? So if not, you need to go back to your chemical class. All right. So if you dip, if you look at this diagram, if you dip 2 copper into this solution, but the solution is same. However, what is different is because of the different concentration. On the left will be 0.01 mole. On the right will be 1 mole. You will see that there's electricity happen between left and right. Right? It will automatically create positive and negative polar between the 2 probe that you use. Okay. So this is one of the way that the electrochemical reaction can be initiated. Okay. All right. Now, how these PowerPoint slides or how this today lecture will help you. Okay. Now, in test or final exam or even in your assignment, we won't directly ask you about how electrochemical reaction can be initiated, because all this information will be on my PowerPoint slides. The question will not be so direct, but it will be part of the question. For example, later you will learn about the chemical reaction. You will see some in the question. You will see something. Just give you some idea, right? So in the exam or test, you'll be given element. You're given a solution. Then maybe you need the help from the periodic table to generate equation 1, equation 2, and so on. Then after that, you balance the chemical reaction. You explain why corrosion can happen in that situation. So the question that you get in test or final exam or even assignment will be a scenario based. So I'll give you a scenario. Let's say you have element 1 and element 2, and maybe I give you a different concentration. Then you explain how corrosion happened or how to prevent the corrosion. Okay, so these are the points that we're looking for in your answer when it comes to test or final exam. Okay, so this factor will trigger the corrosion through electrochemical reaction. First, metal impurity, different concentration. All right. Third one, when you have again same metals. Again, keyword in corrosion module is metals, because corrosion doesn't happen in other material other than metals. So for example, corrosion, you don't use corrosion word for plastic, right? You don't use corrosion word for silicon, right? So you only use for metals subject. So again, metals impurity. Second, same metals but different concentration, same metals, the third point, same metals but different temperature. Okay, so these 3 points will help you to elaborate in test or final exam when it comes to prevention of corrosion. There will be one particular section in a question asks you, how do you prevent and why do you use that method? So you start by answering what will trigger the reaction and how you stop the reaction. Okay. Temperature. Okay, so these are the highlights when you have different temperature. So what happens if you have a different temperature? So definition or when you have different temperature means you have one side low temperature, one side high temperature. So the one that have low temperature, it will become anode. The one that have high temperature, it will become cathode. Okay, so once you have different temperature, you have positive, negative polar, or you have anode and cathode. So different concentration also just now in the diagram just now, you also have anode and cathode. So anode and cathode is a keyword when you answer your question, right? Any question for these 3 points? Anything that you're not sure? These 3 points will trigger electrochemical reaction in metals and alloy. Okay, in metals and alloy. So as long as these 3 factors or environment have impurity, you have different concentration. If you use the concentration word, it means it must follow by the same metals or identical metals. And if you need to use the different temperature to answer for electrochemical reaction, it must also refer to the same metals. You must put same metal together, then only you can initiate the electrochemical. Of course, different metals you put together also have electrochemicals reaction, but we are more focusing on corrosion control later on. So this will contribute to corrosion. Okay, any questions so far?
So far, no questions.
Good. All right, huh? Okay. Right, so we have done with the factor, we have done with the corrosion process, the definition of corrosion, and I think you are ready for one of the test 1 question or one of the part of in the final exam, right? All right, next we look at type of corrosion. Okay, we look at type of corrosion. So I'll give you all the factor. Now, corrosion can classify by all these terms. Corrosion can be classified by natural corrosion, environment or electrochemical corrosion. It can be temperature corrosion. It can be corrosion attack and the attack rate. So you can look at either it's happened in nature or there's an imbalance in the electrochemical properties, or there is an imbalance in temperature, means one side high temperature, one side low temperature, then you get anode and cathode, or there is a corrosive element nearby that initiate the attack. So sometimes there will be, we have covered the definition of corrosion. So if you dip 2 elements in a solution and one side contribute electrode or E negative charge into the solution, then this corrosion attack will happen. Then another one, we can classify corrosion by observing the attack rate. how fast or how low the corrosion happen. Okay, so these are the general classification: natural, their chemical properties or electrochemical properties, temperature, how they attack, and how fast they attack. Okay, so this is how you classify your corrosion. Be sensitive to the word classified. Classified means how you differentiate them. Now I introduce you another not technical, but another keyword we call form. Okay, 9 different forms of corrosion. Don't confuse with form and classification. Okay, so these are differences between classification or classified, how you classify your corrosion. Don't give the wrong answer when it comes to your test later on. When the question asks you to classify, look carefully. It falls between either one of these. When it asks you to explain form, don't put classification answer in form. Okay, you have 9, so don't confuse form, corrosion form, and corrosion classification. Don't confuse these two. Huh? Okay, we look at the first one. First one we call uniform attack. Uniform attack. So the first form that you see in the corrosion, we name it as uniform attack. Second, galvanic corrosion. You learn the word galvanic in a chemical class. Galvanic can be explained using periodic table when there is an exchange of negative charge. All right. So when your metals release or receive electron, then galvanic process will happen. So the first one, uniform attack. Second one, galvanic corrosion. We will look at each one of these in deep later. So we'll introduce you the name of these 9 forms: uniform attack, galvanic corrosion, pitting, crevice, or later I'll show you the diagram. Next one is stress, intergranular, selective, corrosive, erosion, hydrogen. 9, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So copy this name somewhere in your notes. So we're going to look at uniform attack later on. There are 9 forms. So each one of these they have their own characteristic. Okay, there will be one essay, not essay, but there's a long question in your assessment or in your assignment or in your test or final exam to explain by looking at I'll give you a scenario, I'll give you a picture, then you describe according to the form. Okay, you start describe by saying the characterization of corrosion, then you followed by form. You look at the picture, right? You look at the picture, and then you explain whether it fall under which type of, which form of corrosion. Okay. So I'll give you another maybe 10 seconds to copy. So you have 9 forms. Move on. A researcher called Dillon, his method of grouping corrosion, he grouped into 2 categories according to Dillon. Right? This researcher or this scientist or material scientist group corrosion into two categories. First, the group corrosion. The first group fall under visual examination. Just now we have 9, right? We have 9 types. So along these 9 types, Dillon grouped them into two main categories or two main families. Just now the nine form of corrosion. Dillon grouped them into two big families. First group, if you can identify using visual examination, means you can look and see and measure, then it falls under group 1. Second group, you need to bring the material, you need to bring the sample, go into the lab, use special equipment to extract the data. So if you need a careful examination, the keyword is examination and identification, means it falls under group 2. Again, group 1, visual examination, means you can inspect the condition by looking at the surface. Then if you can tell by looking at the condition on the surface, then it falls under group 1. If by visual is very confusing, you don't know whether it is which form of the corrosion, and you need to bring that to lab, you need to cut the material, use microscope to see, use ultrasound to see, then it falls under group 2. Okay, so 1 is more simpler, means by using your visual eyes, use your eyes, then you fall under group 1. If you need to send to lab, you need to use a magnifying glass, you need to use microscope, you need to cut the material, then you fall under group 2. First one, if you can visually check one of the form of corrosion, the first form fall under group 1 is uniform corrosion. Okay, uniform corrosion. So later we'll look at what is uniform corrosion. The word uniform tell you the word means there's an even loss of material. Okay. Second, galvanic. Galvanic means it involves positive and negative charge. Then you will see something happen. In previous lecture, I show you a video. I show you a video with metals that change color. So that is one of the visual examination they can do. All right, because if you have a positive charge, negative charge in the metal, you will see change of color. So this is one of the form of the corrosion that you can group under group 1, galvanic corrosion. Third one, pitting means hole. Pitting means hole. You can see hole on the surface. Then it falls under visual group 1. Group 1. Pitting or stain. So stain means a spot that with dark color or chocolate color or something that you can differentiate from other surfaces, right? Pitting or stain. This one you can see from the surface one, right? Then after group 1, we look at what are other can group under group 2. So basically, you take out the 9, you pick 3 from the 9 form just now that fall under group 1. The rest you need fall under group 2. So you have erosive. We'll look at erosive later on. Interglonar, you see the word granular. Granular means you need to use microscope to look at the grain, right? I'm not sure whether in one of your module when you learn about material, so under material module, you will you should already learn what is grain, right? What is grain? So when the corrosion happen under intergranular form, then you need to use microscope to check it. Okay, because it's too small. Sometimes you need special equipment to observe the corrosion. All right, and this one is very dangerous if you're in the aviation industry. This one will create micro crack. Micro crack means crack that very small, but when you continue to give stresses or forces, or you continue to do work on the surface, the intergranular corrosion can create from micro crack to crack. So it's very dangerous in when it comes to aviation industry. All right, especially on the wing section, landing gear section, and also some of the sensitive part. Right, so this one, when you come to industry, if you work in the inspection, surface inspection area, then this you need to carefully observe, right? Carefully observe, because this one you need a professional to observe, right? So, all right. The next one is de-alloying. De-alloying means, D means you remove. You remove some element in the metal, right? So the word alloy means you mix different metal together, you become alloy, right? So this one you learn in your material class. So if you mix different alloy, different material and different metals together, it become alloy. So de-alloy means you take up the material from the process. Then you have a change in the you have a electrochemical process happen. So you will try to dissolve one of the elements. So you will change one of the metals into another component, another element. Okay, so this one you need lab test to see. Sometimes you use SEM instrument that will plot element of the solution to observe whether there's a extra or there's a production of a new alloy or in the solution. So this is de-alloying. And then environment cracking, this one is due to stress and fatigue. So this one also will contribute to the micro crack. So you need to use a special lighting or instrument to check. Okay, so this one okay. So later we'll see all this. So these are important for this slide is that you know that Dillon categorized corrosion into two groups. One is using visual. One is use careful examination. Okay, so 3 examples here, 4 examples here. Okay. Okay, I think this one is quite done, right? Oh, there's one more. Microbial activity. The word microbial more on the biology, more on the fungus, more on the biological process. When you have when you have bacteria, then bacteria will release some of the chemical. You know that bacteria can create acidic or maybe alkalic environment. And in previous class, we already learned about how corrosion happen, right? In acidic, what happened, right? In acidic environment, what happened? Okay, so microbial or organic process happen, then there is an acid inside there. Okay, acid will cause oxidation. We'll learn about the detail about this one. Okay, now what is important on this slide is, again, you know that there are 2 ways to differentiate, or 2 big family in category. according to Dylan. This one according to Dylan. Okay. Let's look at the first type or first form, uniform corrosion. So uniform corrosion, as you can see from this diagram, means the corrosion process happens to eat or destroy the element in the uniform rate. As you can see, the dot here is all the decomposed surface, and at the end you will see a flat surface have been observed on the area of corrosion. Then it falls under uniform corrosion. How do you monitor the uniform corrosion? How do you know? Right? How do you know that there is a uniform corrosion happen? Okay, although by visual, right? Although by visual. So how do you know that there is a uniform corrosion happen? How do you know? And usually the changes of this one is very, very small. How do you know? Okay. How do you know? How do you know that you have a uniform corrosion? Can you relate this diagram and this diagram? Let's see. What do you think? Okay, I'm going to ask question. Mohit, are you there?
Yes, sir.
All right. Mohit, for uniform corrosion, you know that we under uniform corrosion, there is a surface missing in a uniform rate. How do you observe the corrosion happen? I mean, if you're given this photo to identify, oh, this one is a uniform corrosion. How do you know?
The thickness
Again,
of the wall.
the thickness. Just now you mentioned something, right? Because your mic is a bit.
The thickness of the wall, I think.
Okay, the thickness of the wall. How do you measure the thickness of the wall? If you have a long pipe like that, how do you measure? Start to think, how we're going to test you in the test or final exam, or even assignment. How do you access, or how do you make examination? Right, it's for under visual, right? How do you know? I'll give you hints. You see in this photo, what is the difference from this area and this area? Or even this area. You can compare, right? This one and this one. What's the difference?
One is rusted, one is not.
The keyword is because it falls under group 1, so by visual. So if you mention measurement, if you mention measurement in your answer, it falls under group 2. If it falls under visual, means you by visual inspection, means you can see this coloration from the initial, a new one, and the old one. Okay, so this one we are lucky to able to capture the differences. So if you work in the industry long enough, you know by visual you know what is a new parts and a corroded part. Okay, so this one is a very drastic or significant difference under uniform corrosion, whereby because you can see the thickness of original to the present condition is very, very small thickness. All right. you need to use under microscope if you really want to inspect this condition. You need to cut the material and compare side by side the new and the old one. Then only you can see this one. Okay, but normally by visual inspection, by comparing the new parts and the old parts, because it's fall under visual and also uniform corrosion, you can see that there's a discoloration, right? New color and the old color. Normal metals, you will see this kind of color. But if your devices, right, these vessels or devices is made of different alloy or alloy material, you will see different color on the surface. Sometimes it turns black, sometimes it turns blue. All right, sometimes you can spot from the painting. Sometimes you spray special paint on it to identify there's a corrosion. Then you can spot. Okay, and also visual inspection. You can use your hand. Your hand is your very good sensor to rub the surface, right? Not rub, but to touch the surface, right? From one point to another point, and you can feel that there's a flat surface. There's no hole. There's no like uneven surface. Okay, you start touching the surface with your hand, and you can see there's a very even surface, but the whole surface already changed color. So this is how you identify it's fall under corrosion. Okay, there is a uniform thickness reduction. Okay, this is another keyword. But from the name itself, from the form itself, the name of the corrosion form, uniform corrosion itself, you know that the thickness reduction happen in a uniform manner. Okay, or you can use diagram to explain. Okay, so just now you see the diagram, right? So if you expose these metals or alloy devices pipe in the atmosphere, then you will see this kind of corrosion happen. So one example is under atmospheric corrosion. So you can say uniform corrosion and atmospheric corrosion. As atmospheric corrosion is more on the environment, okay, more on the environment. So uniform corrosion, when you use the word of uniform corrosion, you describe how the corrosion happened, right? And when you need to use the word thickness reduction in your answer, then it falls under uniform corrosion. And when you're being asked what contribute to the uniform corrosion, so you can say atmospheric or natural corrosion. So atmospheric corrosion is the one that you see on this picture. So on the bridges, on the structure that exposed to the atmospheric, and sometimes if you are staying near to the sea, those houses that built near to the beach, if they use alloy or metals, you'll see that the metal parts of the house will get corroded. Okay, so this is part of the example, right? So another word you can extract from here is that in Malaysia, how do you observe uniform corrosion? You can go to the railway, all right, KTM railway, some old railway or abandoned railway, then you will see it fall under uniform corrosion. Okay, a normal operation one, normal it's very hard to observe because they always maintain the railway. So, and also when there's a movement, then part of the corrosion was removed due to the motion, right? So if you want to observe uniform corrosion or atmospheric corrosion, then you can go to the abundant railway that change color like this one, okay? This color. So this one all you can read. So how do you control uniform corrosion? Okay, how do you control uniform corrosion? Again, you see temperature come up. Temperature, humidity and redness is the same. Or the third point is more on the time of exposure. The longer you're exposed to temperature and water, humidity is because of water, right? Since the first class, when we discussed about the corrosion equation, water involved, oxygen involved. So when you have humidity, then you have both elements, then it will trigger the corrosion. Temperature that we have learned this morning, that when there's a different temperature, high and low temperature, then you have positive, negative, you have cathode and anode, then corrosion will be initiated. Okay, and the pH of electrolyte. pH means by looking at pH level or pH value, you know one side you lead you to acidic, one side lead you to alkalic, right? So one of the one of the reason corrosion happen is because of the acidic environment. So pH also one of the player, right? So you can control the pH. Okay, you can control the pH. And how you elaborate this point when it comes to your assignment, how you elaborate the pH point, how do you control the pH point? Let's say I give you a scenario. The environment pH was maybe 5. How do you control it? Last question. Ngan Chinlong, Ngan, are you there? So
yes,
let's say you're having a scenario. Let's say this bridge or this railway exposed to environment, and you measure the environment pH is 5. How do you control it? How do you how do you stop the corrosion from happen if you measure the pH of the environment is 5?
Maybe add a layer of the material which is having high corrosion resistance on the surface of the railway.
Okay, so how do you handle the pH problem? The pH problem is 5 now. The value pH is 5. How do you reduce the pH level? Just now you say you spray something on the surface, right? So spray something on surface doesn't help on the pH, right?
Yes, sir.
So how do you control pH? Recall back what you learned in chemical class. How you control pH? How you change the pH value? Now you have 5. The pH value is 5. How you control it? Because you know that corrosion will happen in acidic environment. So 5 is acidic, right? So how do you reduce the pH?
So is it like added some alkaline solutions to neutralize the acidic solutions?
Okay, so that the pH value will go towards what?
Towards neutral, like near to pH 7.
Okay, right. So that is the answer we're looking for. Okay, because the issue here is more on pH and not on the how you insulate the things. Okay, so when you look at the question in test or when you go to work later on, you need to very specific identify what is the problem, and then you solve it with the correct solution. Okay, right. So we learned something from non-answer just now, right? So try to think. how do I apply in my work later on. Okay. And again, for your test or final exam, it will be a scenario-based kind of question. Right? So you need to look at the question, identify the keyword that mentioned. For example, I mentioned pH in the question, then you need to give solution targeted to that particular keyword. Okay, maybe I mentioned temperature, I mentioned humidity. Humidity, sometimes I use a keyword near to river, or I use the word tropical country, like Malaysia. In a jungle, then humidity will become one problem, right? And how do you know to settle to solve time of wetness? Sometimes I mention if you build something, you need a strong structure that go into the soil, right? So maybe I will ask you something that, or maybe I'll give you an example of a boat made of an alloy, the body made of alloy, and it was abandoned at the river for maybe for a long time, 5 years, never touched it before. Then it fall under factor of time of wetness, humidity, and change of temperature. Temperature, you need to look at the question. Sometimes temperature is very direct mentioned in the question. All right, the next one, the point here means there is a pollution or pollutant or contaminants in the environment. All right, most of it will contribute to the acidic environment. Okay, so uniform corrosion, you can look at all these factors, right? All these factors. So we have done uniform. Next, we look at galvanic corrosion. Again, the word galvanic is positive. When you see the word galvanic, it means positive, negative sign. So it means you have a different potential, right? Positive, negative sign, then you have a different voltage between one side and another side. So different potential is the word of link to galvanic corrosion. So when you learn about simple electricity, simple electronics, right? So you know that when there's a different potential, then the current will flow from high to low, right? So then you know that when the electron is flowing between 2 points, then you know corrosion will happen, right? As what we cover in our first lecture, right? By looking at the corrosion equation, you know when the exchange of E negative or electron, then you know corrosion will happen. So this one fall under galvanic form. Okay, so these are the keyword for galvanic corrosion. What do you need? You need two metal or conducting material. For galvanic, to have positive, negative, or different potential, you need two metals in that scenario. You need one side metal, one side metal. Then these two metals must connected together. Okay, two metals connected, and I highlight the electrically connected means they are exchanging the electron. So there's a flow of electricity between the two metals. So two metals, they are connected, right? And there's a medium for them. There's a medium for them to exchange the electricity or electron. Okay, so this is a keyword when you explain about galvanic corrosion. Right, you need two metals, you need a medium, and these two metals, they are connected. Okay, so this is another diagram that fall under galvanic corrosion. So this diagram is very famous in shipping industry, where the shipbuilder control corrosion at the bottom of the the boat. Okay, they will install some material below the boat, then to control the corrosion. So this diagram is simplified diagram. So as you can see here, there are two metals that exchange the ion. So cathode will go to anode, then anode will, if you release electron, then some element will become positive charge. Positive charge can go to into the air, mix with the water, oxygen, then it becomes something else in the air. Then it will, when it becomes something else in the air, then it will drop because of the, it becomes solidified, become a full molecule, then it will drop back to the, deposit back to somewhere on the surface. Okay, so this is a schematic diagram for galvanic corrosion. This is another example. This one is on the pistol. Okay, but however, what is important here is how galvanic corrosion look like. It look like snow shape. Right? It will look like star shape. Right? It look like star shape, or you can say it look like a tree root. You know, the tree root behavior on the surface. You can imagine because of the galvanic process or galvanic corrosion, you can imagine as you can imagine as firecrackers. When you burn firecrackers, it will look like firecrackers effect. It will burst and then it look like all this. Okay. So this one will happen in most of the electronic part, or there's a different potential of positive, negative on the metals. Okay, when there are two metals that have different, two metals, they are connected together. Now, most of the time you'll see at the connecting area, you'll see all this sign on the surface. Okay, so what else? Okay, so factor. Okay, factor that can control this one. You can read from my slides. Okay, you can read from my slides. They are how many are there? A to G. Okay, A to G. So from my slides you can read, right? So basically the whole idea is there's a different potential happen in between the positive, negative side, between the anode and cathode, and they are connected. There are two metals. They are connected, and they are inside a medium. So because of they are connected metals, they are different potential between them. Then you will see anode and cathode, and you have all this. So you have reversible. You install oxygen reduction. You control the oxygen, hydrogen. This one is more on the first equation. The second point B there is more on the equation that we learned in our first lecture. So first lecture is very important. So as long as you understand first lecture, then the rest is just reasoning of how we control it. Okay. So then the third one, you do heat treatment and so on. Right? Then what else? And this one, electro properties. You control, again, you control the pH, conductivity, temperature, flow rate between them, right? Yeah. Okay, so this one you read from the slides. Okay, I think we stop here. Okay, we stop here. We will look at Maybe you go for one more, then we stop. You go for one more, then we stop. Okay. All right. So we have covered two: uniform corrosion, we cover galvanic corrosion, and we cover one more: pitting and strain corrosion. Pitting and strain corrosion, I will simplify in a bracket. They are localized corrosion. What does it mean? Pitting means you'll see hole on the surface that you can see by, or you can inspect by visual examination. They are localized. Localized means at that fixed position. Okay, in that fixed position, and you see a hole on the surface. Okay, extremely localized means right on the spot. Okay? They penetrate metals, and this is a very serious matter, or they're very serious corrosion that we will prevent at all costs when it comes to products, end user products, because it will make equipment failure. Okay. Because this one, sometimes it make holes and it make the equipment fail because of the connection inside the devices. Because the weight is very, very small. The loss of the material weight is very small. Is very hard to detect based on weight itself. Right? So I'll give you some example. This one is for the marine, under marine environment, and this alloy surface was having a pit. You see there's a localized, there's a spot here, spot here, spot here, spot here, and they're round, in the round shape. One spot, and if you look deeper, you see there's a hole, shallow hole here, right? And if you do not control this one, it will go deep inside, and it will make the equipment fail, because if when you have a hole, and this one when it contain pressure, then maybe the liquid will flow out, and there's a leak on that component, and the leak will make other component fail. Okay, so this one is you need to control, and this one you can prevent, because this one you can check by visual inspection. This one normally happen in the area where it is very difficult to go in. Area that a narrow space, a small space, but the component is there. So this one usually they only check this one during annual inspection, equipment annual inspection. They will open up the equipment and then check every spot. So this one normally will only spot during the annual inspection, right? Because normally this pitting corrosion or strain corrosion will happen in the area where it's very hard to access by human, right? So again, what is important is that you see what is the difference between uniform corrosion, galvanized corrosion, and pit or strain corrosion or stain corrosion. Pitting means hole. Stain means you see that this is a stain. Stain means you like oil color, black oil color. Stain, like a stain, right? Sometimes you see discoloration, but there's a hole there. Picture A is a copper pitting corrosion. And this one, if you have an old drinking water system, you go to the old house, old neighborhood, or less developed country, when they use copper in their drinking water system, then you will see this diagram. You will see something happen at the wall of their pipe that use copper, and this is a very serious condition already. Okay, So it will start with a small pit like that. It start with something like this. And then if you do not control, it will become larger and larger. And this one is a very serious matter. You need to change the part already. And then this one is you cut the part and then you observe under scanning electron micrograph, or SEM. Okay, so SEM is a method that we use a high-powered microscope where you can magnify the surfaces. Let's say you look at that spot and you zoom in this spot in 600 micron meter. Means you zoom very in to the surface. In this one, you see the scale inside the photo, 600 micron meter, very small area. Okay, and today recap what is SEM? Scanning electron micrograph. Okay, scanning electron micrograph, or SEM. So it's a very popular method when you learn about material. Almost, I can say almost near to 99%, if you study material, you cannot run away from SEM. Okay? You need to do some observation on the surface. All right. Perforated, this word, perforated, pit, you know, pit is a hole. Perforated means there is a hole that go through. We call perforated, right? Or you can say perforate. If you say perforated pit, a perforated pipe means the pipe is having a hole that you can see through, right? Another side. Okay, so perforated means there's a hole there. There's a hole that you can go through from one side to another side. It's called perforated. Okay. Okay, I think we stop here for today. I'll end the recording.